As I stated in the description of this lecture, it's just a continuation on angles. There's about 4 more slides I wanted to get to give you more examples on solving even a little bit more complex diagrams involving angles. And I always encourage students when they're taking tests to just start by writing down the angles that they can figure out real easily, and sometimes those lead to the more difficult ones, as you'll see probably on the next slide. This one's pretty straightforward. You can see for sure this is not drawn to scale. There's no way this is 58 degrees. That's more than 90 degrees, but it's labeled 58, so we're going to go with what it says. If that's 58 degrees, I bet you agree that this angle plus the 58 degrees have to add up to 180. Those are definitely supplementary. So if we take 180 and subtract 58, we'd get 122. So angle X is 122 degrees. Now, do you remember from earlier that angle X and angle Z are called alternate interior angles? And alternate interior angles are congruent, so angle Z is also 122 degrees. And then angle Y, you can figure that out 2 ways. It's supplementary to 122 degrees, or it's alternate interior with this 58 degree angle here. So that's going to be 58 degrees. And like I said, those are definitely not drawn to scale. Okay, this is an example of a little bit more complex diagram, and don't try to find just any random angle. Like, don't go up to angle 2 and say I'm going to try to find angle 2. What you need to do is start writing down the ones you can figure out. So if you look down here and see that 120 degree angle right here, well, if that's 120, then angle 8 is 60, because these 2 angles right here are supplementary. And once we know those 2 angles, if angle 8 is 60, then angle 7 is 60 degrees, and angle 6 is 120 degrees for a couple reasons. You could say it's because it's vertical to this one, or you could say because it's supplementary to this one. But we've now gotten those 4 angles taken care of. Right here we also see that they told us this is 55 degrees. Well, then that means this one's also 55 degrees because those 2 angles are vertical. They form an X where those 2 lines intersect. And then we're kind of stuck right then unless you notice this. If we take a look at this 120 degree angle right here, these 2 lines are parallel. Okay, that's what those arrows mean, is they're parallel. So if I slid this 120 degree angle up that line right here, up this transversal line, then that 120 degree angle would fit perfectly right there. In other words, that 120 degree angle is corresponding to this angle that I just drew in red. Well, we know that a portion of it's 55 degrees, so the other portion of it, which is angle 2, is 65, because 65 plus 55 add up to 120. Now we know that if angle 2 is 65, angle 4 is 65 degrees, right? And then we also know that angle 1, 2, and 3, if we look at these 3 angles right here, they have to add up to 180 because they form a half of a circle there. Well, 55 and 65 is 120, so angle 3 is 60 degrees, which means angle 5 is 60 degrees. Now we could have got angle 5 being 6 degrees by looking down here, because this 60 degree angle would have slid right up the line and been corresponding to that angle there. So that's another way to find out that was 60. Okay, now how in the world can we find 9 and 10? Maybe you guys noticed that if we know this angle 65 and this angle 60, and we have one more angle in this triangle, we know these 3 angles in the triangle have to add up to 180. So 60 plus 65 is 125, so 9 has to be 55 degrees because 125 plus 55 is 180. Now someone else might have said, wait, I would have done it this way. This angle right here and this angle right here are alternate interior angles. So that's why I know it's 55 degrees. Whatever method you use is fine. And then once we know angle 9 is 55 degrees, we know the measure of angle 10 is also 55 degrees. So that is a fairly complex diagram, but by taking it a step at a time and using the knowledge we've learned from lecture 1, we could find all those angles, or the measure of all those angles. Here's another one that's fairly complex, and if you notice, they only gave us a couple different angles here. They gave us 160 degrees right here, and they gave us 60 degrees right here. So we definitely can't just jump way over to the right and try to figure out the angles over here. We have a little bit of work to do. Well, let's start out with what we know, because that's the advice I gave you guys, is when you don't know what to do, start with what you know. If that's 160, we know this is 20, right? Because 160 plus 20 has to add up to this 180 degrees right here. Those were supplementary. And then we have a little triangle formed here, and this triangle has a 20 degree angle, a 60 degree angle, which adds up to 80. Those two add up to 80, so this angle right here has to be 100, because 100 plus 20 plus 60 is 180. And if that's 100 degrees, because of vertical angles, that one's 100 degrees. So we made a little bit of progress so far already. And now we have to say, well, where do we go next on this? Basically, to be stuck right here, and we couldn't go any further unless we notice something. And what you need to notice are these arrows here and here. Those arrows mean those two lines are parallel. And if those two lines are parallel, we have two parallel lines cut by this transversal right here. So if that's 60 degrees, that angle right there is 60 degrees, guess what? That angle there is also 60 degrees. Because they're alternate interior angles. And then if this is 90 degrees right here, this angle right here is 90, which means this angle has to be 30 degrees, because 60 and 30 adds up to 90. Now we're making some progress. We have a triangle here. We have a 100 degree angle, a 60 degree angle, and then we need to know that angle, so that has to be 20 degrees, because 100 plus 60 is 160 plus 20 adds up to 180, and if angle Y is 20 degrees, angle P is 20 degrees because of vertical angles. And then angle R would be 160 degrees because it's supplementary to angle P. It's also supplementary to angle Y. So like I said, you just start with what's given to you and take it from there. Alright, one more slide here. We need to figure out the value of X here. Well, we definitely see a triangle there, so let's try to figure out the three angles in the triangle. They don't give us all three, but we can figure out all three. Because of the fact this is 132, we can figure out that this is 48 degrees, because 132 degrees plus 48 degrees adds up to 180. Now we know this 48 degree angle plus this 93 degree angle here plus this 9x plus 3 degree angle here have to add up to 180. So I'm going to write that down. 48 plus 93, 48 degrees plus 93 degrees plus 9x plus 3 degrees has to add up to 180 degrees, right? Well, we have 9x, and 48 and 93 would be 141 plus 3 is 144. I believe those three numbers right here. I believe these three numbers add up to 144. Okay, and that adds up to that equals our 180. Let's subtract our 144 over. By the way, these are the type of problems you'll see on my math lab. At least some of the problems will be like this. 9x is 36 degrees. So we divide both sides by 9 to get x equals 4. So let's put a 4 in for x here. 9 times 4 is 36. 36 plus 3 is 39. So supposedly that's 39 degrees. We know we're right if 39 plus 93 plus 48 adds up to 180. And let's see, 132. Yep, it does add up to 180. So the one thing I haven't talked about in our lectures is what if I wanted to name this angle right here? You could call it angle REB or angle BER, but the E would have to go in the middle. So we go from R to E to B. When I go in that order, I'm coming over like this and then going down like this. So that forms that 48 degree angle. Or if I started from the B up to the E over to the R, that also forms that 48 degree angle. So on MyMathLab, if you see things written like this, that's how you name angles. I could call this angle right here just angle R, because there's nothing else going on with that angle, whereas E, there's a bunch of things going on. We couldn't call this angle E here because we don't know if we're talking about the angle on the right or the angle on the left. So this angle up here could be called angle R, or it could be called angle ERB, or it could be called angle BRE. You could even call it like angle JRB if you wanted to. Came over from J over to R down to B, and that would be JRB. Okay, I think you get the idea on naming angles. There, that's it for angles. You've had 2 lectures on angles. Hopefully that'll help you on the angle problems on MyMathLab. Bye.